In this video, I want to give a brief overview of the general plan for this course. We'll have 4 different units that we'll use to divide up the different topics that we'll be covering. So in the first unit, which will be the first 3 weeks of the course after this one, this first week is Unit 0, which is course introduction and some structural anatomy review. So starting next week, we'll start Unit 1. That's going to have things like planes of motion, axes of rotation, how the joints of the body move, how we can think about that, both in terms of like simple joints and in terms of more complicated joints, like maybe the shoulder girdle. We'll talk about concepts like degrees of freedom, statics and dynamics, and we'll do an introduction to some medical imaging because that's going to be really useful for actually taking a look at how things really work and how things really look inside the body. So one example of that might be in this software here, we can take a look at how the body moves, and we'll learn about how do we describe motions that happen in a plane like this, hip flexion and hip extension. How do we describe motions that maybe don't necessarily happen just in one plane, like what happens at the foot during walking or running. We'll also review some terminology that you've probably heard before in terms of orienting ourselves in space regarding where the body is, where different parts of the body are relative to one another, and how different joints, different segments of the body move relative to one another. So that'll be Unit 1. Now in Unit 2, we're going to be taking a look at what happens when we start applying loads into the musculoskeletal system. So first we'll learn about what is inside the musculoskeletal system, so bones, tendons, cartilage, ligaments, nerves, what differentiates all of them, and then we'll start looking at what happens when you start actually applying mechanical loads to those. As you might imagine, that will become very important when we're trying to think about how do these different structures of the body respond to being physically loaded, either in the case of exercise, in the case of daily living, or in the case of an acute injury like an ankle sprain. So we'll look at different structures like maybe the bone right here, like the muscle around here in this light gray area. We'll look at tendon, look at cartilage, and what dictates how each of them responds, both in terms of healthy responses and in terms of what we would call pathological responses, right? Those that cause injury, those that cause disease, or those that are the result of a disease. Now in Unit 3, we'll start looking at how the generation of forces inside the body translates into motion at a joint, motion in space. So one of the big things we'll be looking at is once your central nervous system sends a signal to a muscle, how does it start creating force? And how is that force that it creates modulated by things like whether the muscle is a slow twitch muscle or a fast twitch muscle, the length of the muscle fiber, the velocity that the muscle fiber is moving at, and even the current state of activation of the muscle. All of these things are going to dictate how much force a muscle can produce, and that's going to be really important both for sports and health applications. Now, by doing that, we'll be able to understand how is the body going to be able to move during action like running. You can see here in this simulation that the muscles are lighting up from blue to red proportional to what level of activation they are being recruited at. So we'll be able to analyze, for example, when are the calf muscles, which you can see lighting up right now, when are they contributing most to pushing off the ground and why? How might that go wrong in cases of injury? What kind of musculoskeletal diseases affect your ability to recruit your muscles? And how can you train an athlete to improve that ability or improve the properties of the muscles themselves, say for sprinting performance, endurance performance, vertical jump performance? So that will be Unit 3. And finally, in Unit 4, we'll be looking at specific applications both in sport and in health. So we'll take everything that we've learned in the course and we'll apply it to things like acute injuries, like an ankle sprain, overuse injuries, which are one of my research interests, like stress fractures, tendinitis, musculoskeletal disorders, both things like cerebral palsy and things like recovering from a stroke. We'll also take a closer look at how do all the principles that we've just learned apply to specific joints. So you might be particularly interested, say, in throwing motions. Those are very dominant by the shoulder joint, right? You might be very interested in shoes or footwear, orthotics, maybe podiatry. That's going to be very dictated by the ankle joint and the subtalar joint and the smaller joints in the feet. Likewise, we'll look at the torso, we'll look at the upper body, lower body, and apply everything that we've learned to try to solve some real problems that you may encounter in your career, whether that's a sports-related career or a health-related career. So I hope you enjoyed this brief overview of the course, and in the next video, we'll talk about some of the specifics about how this course is actually going to work.